All right, now that we've seen how we can understand a binary tree that's been manually set up to be a binary search tree, let's talk about how we can automatically mutate it or add or remove values from it while satisfying this binary tree invariant, binary search tree invariant. So we want to add or remove things while making sure that the left subtree of any node has all keys, I'm going to call them keys now, less than the node's key, or that the right subtree has all keys that are greater than this node's key. Now the reason I'm calling them keys instead of values is because we might want to actually use this data structure to act like a map, just like the hash map where we look things up by the key and then we have values associated with them. For now I'm going to use it more like a tree set. So it's just going to store some values without duplication. I'll call them keys though because they don't actually have things associated with them. But we might later want to have a value. You know, you might want to add a value and then maybe change that value if you're trying to add something that's already there. So you can have a put method. Okay, whatever. But for now, we're just going to have these keys. Okay, and they're unique in each node. And we want to continue to maintain this invariant of the binary search tree. Okay, with the less than or greater than with the subtrees. Okay, so let's look at a picture and think about how might we add something to this tree. So let's say that I wanted to add the value 6. So let's just think about where that would go. So we know things about this binary search tree that we're trying to maintain, and we know things about how it is now. So what I know is, okay, if I'm going to maintain the binary search tree property, you need to make sure that 6 goes to the left of 10, right? Because 6 is less than 10, so it needs to reside in the left subtree. Okay, now I'm at 7. Well, it should also go to the left of 7. Okay, now I'm at 3. Well, it should go to the right of 3, but I actually find that 3 doesn't have any children, so what we can do is create a new node and put 6 there. All right. So let's say now that we wanted to add 5. To do the same kind of thing, well, it's going to have to go to the left of 10, it's going to have to go to the left of 7, it's going to have to go to the right of 3, but actually to the left of 6, right? Okay. And let's maybe do one more. So how about, what if I wanted to add 17? So 17, well, that's going to have to go to the right of 10. Let's go to the right of 10, it's going to have to go to the right of 16. But actually to the left of 20, I find there's nothing there, and it actually becomes the left child of 20. All right. So let's see if we can write this in code, something like this. So I'm going to make, just kind of like I did with the in order before, I'm going to make just almost like a skeleton method here. Whoops, I'll be adding a key. So first thing I'll do is, actually the base case is the whole tree is empty. So I'll say, you know, if self.root, then I'm going to want to add this starting at the root, have some kind of recursion. But actually if the root doesn't exist yet, we have a pretty easy job here. We just make a node and make this the root. It's like when you're at a linked list and you try to add something, but there's nothing at the head, so it just becomes the head. So I'll say self.root equals tree node key. All right. But otherwise, I'm going to have to do some recursion. So let me fill in this add method up here. So if I'm adding you at a node, what I have to do is say, okay, you know, exactly what I was doing in the picture. If I found, you know, I was trying to add 6. If I found that 6 is less than where the key that I'm at, I need to go to the left. If I find that it's greater, then I need to go to the right. So let's just try to do that. So I'll say if key is less than self.key. Then I'll go to the left. Now, what does it mean to go to the left? Well, first thing I'll check is to see if there actually is even a left child. So I'll say if self.left, okay, then I'll keep doing the recursion. So I'll say self.left.add key. But otherwise, there's nothing there, which means I've reached the end and I'm able to place this key now. So I'll create a new node, which is going to be the left child of this node. So I'll say self.left is equal to tree node key. Okay, otherwise, if key is greater than the key at this node, I do something very similar. I say, okay, well, if this has a right child, then I want to go there with the recursion. If it has a left, or if it doesn't have a right child, then I can actually make the right child a new node and place this key. Okay, so that should do it. So let's test this out and see. So we start with this tree. Let's say that I add the 6. Let's draw it. Okay, cool. So the 6 went there. Let me do exactly what I did in the example that I drew before. Let's say now that I add a 5. Okay, 5 goes to the left of 6. Is that what we had? Sure did. Okay. Let's go back here and we'll now add the 17. And that ends up over here. And for good measure, let's add a 15.5, which should go here. So let's see if it does. Okay, there we go. Now here's the really cool thing. I've maintained this invariant the whole time. That's what's called an invariant. So if I say t.inOrder, that will actually print out all the numbers in order, including the ones I just added, like 5 and 6 and 15.5. So that's pretty cool. So this is actually one way to sort elements, is by adding them to a binary tree, and then just traversing the binary tree within order. So you call that tree sort. All right. So call this tree sort. So I could start with an empty tree, add a bunch of random numbers. Actually, let me do that real quick. So I'll just say t is equal to, I'll just say, yes, t is equal to binary tree. I'll say for I in range 20, I'll say val or key is equal to mp.random.rand int. I'll say between 0 and 100 maybe. So I'll say t.add key, and then we'll just draw it. Or no, I'll just say t.inOrder. Okay, so I'll print out what the key is each time. And then I'll just say in order, make sure it actually came out in order. Oops, I didn't even use NumPy here. All right, so this is what I got, 50, 0, 1975, but I see when I add these to a tree and then do the in-order traversal, I actually get them out in sorted order. So here's another sort, okay, called tree sort. If I draw this particular tree, let's just look at it, see how it went. Okay, this is the tree that ended up being constructed here. So 52 was the first thing that ended up being the root. 0 was the next thing, that was to the left. Okay, so we got a tree that looked like this. Great, so that's how you add things to trees. So let's take a breath and then talk about how to remove things, because that's a little more complicated.